Okay, this is a video of our first lesson, functions and their graphs. This is 1.4 and 1.5. I'm going to have to be patient as I figure this out. I haven't done this particular one. Okay, I think this is... Yes! Yay! These are our objectives. These are the basics of what we're going to be learning. Alright, functions. Determine whether relations between these two variables are functions. A function takes each item in the original set, and I'm making it shift. Hang on. I don't want it to move. I want to ink on it. Okay, there we go. Let's use red for right now. Each item, oh, there it is. Okay, in the input set, it maps it to one and only one in the output. If I had 5 mapping up there, or if I had 2, let's say 2 mapped all the way back here to 4, then it would not be a function. To be a function, each input, which is my blue box, okay, so this is input, maps directly to one and only one output. With these extra red lines, these are not inputs. Sorry, these are not a function. Without it, it is a function. Now notice, these are called outputs. Notice that 2 of the inputs go to the same output. That's okay. You can't have more than one output for each input. Now on your worksheet as well as in your homework, we're going to be also looking at things like setting these up as pairs of numbers. So the 1 is matched with the 9. And the 2 is matched with a 13. If I matched them all, what I would look for is duplicate x values. If 2 was also matched to 9, then it wouldn't work. It would be not a function. So what I'm going to look for is duplicate x's, plus I need all of these to be matched, to be represented in my pairings. Okay, now we're talking about function notation. I did a blank like this on purpose. You have to understand that whatever goes in the blank in the 1, so it could be anything, absolutely anything. It could be a smiley face. Okay, I'm not real good with the pen on the iPad, so you'll have to put up with my bad smiley faces. It doesn't matter. Whatever goes inside the parentheses goes inside the parentheses in the equation. So here I have an x in the parenthesis, and it's going to give me an x right here. I have a 2 in the parentheses, I put a 2. These are easy to figure out, right? This is 6 plus 2 is 8. Here I have a -1, which gives me -3 plus 2, which is -1. Here I have a heart. It can be anything. Whatever I have inside the f function notation, I have to place where the x was or the blank was or whatever. Alright, so now y is a function of x. Y is a function of x if you can write it as a single y in terms of a function. Okay, so for our first one, I will subtract the 3x. So I have -3x. Well, I'm also going to divide it by this -4. Plus 9, which is also divided by that -4. Oh, sorry about that, I hit that with my hand. Okay. Now, these turns into pluses. This minus turns the whole thing into a minus. So I'm going to erase these and put in a minus. There we go. Oh, I get lots of choices. I wasn't trying to do that. This became a minus. So I have a single y written in terms of x. That's a linear equation. On this next one, I end up with y squared equals, notice it's the same constants. So I know that I'm going to end up with 3 over 4x squared plus, nope, not plus, right? It's a minus because I'm going to divide by that negative 4. So I have minus 9/4. Well, there still isn't one and only one y there. I have a y squared. So it's y equals plus or minus the square root of 3/4 x squared minus 9/4. Now, this is not a function, but if I erased the minus, that is now a function. Okay? Notice by erasing the minus, I can only have one or the other. I cannot have both to be a function. Here I have absolute value. Remember that absolute values were v-shaped functions. Now I have the absolute value over the y, so it's going to be this direction. So I have to split absolute values into two pieces. So I have 4y equals 9 minus 3x, which is going to give me y equals 9 over 4 minus 3 over 4x. But I also can put a negative inside there. So I also have to split this into a minus 4y equals 9 minus 3x. Well, this is going to give me negative 9/4 plus 3/4 x. So now I have two separate functions. If I treat them individually, they're functions, but together this would not be considered a function. All right, now we're talking about domain. This is written out long so because it's very generalized. The main things to notice is when looking to define your domain, you want to look for square roots, variables in the denominator, and logarithms. Square roots have to be greater than or equal to 0. You know this because we don't want imaginary numbers. So basically, x minus h has to be greater than or equal to 0. So x, by adding h to both sides, has to be greater than or equal to h. In my denominator, I cannot have a 0, so that cannot equal 0. X minus h cannot equal 0, so x cannot equal h. For my log, notice that my b is going to be positive, always will be. The x, though, what's inside my log has to be greater than 0. Can't equal 0 either. If you remember, we had asymptotes when we graphed logs. Logs looked like this. It came right up the x-axis, the y-axis, and out. So x has to be greater than h because it has to be greater than 0. Now, if you don't have a square root, you don't have a denominator, and you don't have a logarithm, then basically it's all real numbers. We would write this in interval notation like that. That would be all real numbers, from negative infinity to infinity. All right, vertical line test. We're going to go over it real quick. Remember, that's where if you can draw a vertical line anywhere and it crosses the graph in more than one place, more than once, then it's not a function. All right, these are other definitions for function. Notice on these graphs I have some, look at this. I cannot, no matter where I draw a line, hit the graph more than once. Same with this. This is a cosine curve. I cannot hit it more than once. But this one, notice I've got 1, 2, 3 intersections. So it hits it 3 times, so it's not a function. Here I'm hitting it twice. So it's not a function. Over here, again, each one is hitting it twice, so it's not a function. Here, this one, I want you to notice that both of these little dots are filled in. This, therefore, would not be a function because these two line segments are including this one line. There's some overlap. So that means this cannot be a function. Whereas this second one, notice that these are open circles and the lower ones are closed circles. That means that they don't quite overlap. Almost, but not quite. So that means this would indeed be a function. Okay, this is where you will go and fill out your in-class practice, numbers 1 through 5. All right, you're going to have some function notation, and you're going to have some other kinds of notations. And I'm going to pause it right now. Okay, sorry about that. So you're going to have to determine functions. I told you you're going to have some pairs of numbers. You're going to have some boxes. You just are looking for x's that are duplicated. That makes it not a function. And you're going to look for whether or not everything in the x or in the input box is being represented. All right, so, oh dear, why is that not staying where it belongs? Stop it. I have, and why? It's, oh, because I'm not, there we go. 1 is yes, 2 is A and C, 3 is yes, and that yes is because it is not using the plus and minus. Okay, I'm recording again, and I'm sorry, somehow I didn't get this recorded, so I'm going to erase this screen and redo it for you. And it looks, there's the erase. Okay, so I'm going to erase the screen. I thought I was erasing the screen. People don't do this to me. Okay, I'm sorry. It doesn't seem like I'm going to be able to erase the screen, so I'm just going to talk you through it. When we go to find the zeros, we set the f of x equal to 0. If the degree is greater than 1, we're going to have to factor. So in this first one, I place a 0 in place of the f of x. Then I'm factoring out the x squared. Okay, you can't, let me, in blue, maybe I can, there we go. I'm talking about this one. We replaced the f of x with 0, and then we factored out of the equation the x squared, because both terms had an x squared. Well, I noticed that this factor here can continue to be factored because it's a difference of squares, and it breaks into conjugates, x minus 1 and x plus 1. So now this is going to give me that x is equal to 0. This gives me two zeros, multiplicity of 2, positive 1, and negative 1. So that's my zeros for that equation. On the absolute value, we have to split absolute value apart, but we have to isolate that absolute value before we do that. Plug in the 0. We're going to move the 4 over to the other side. Now we split it. Half of it is going to be over here. Negative 4 equals x minus 3. And then we have to take the negation of what's inside the absolute value. So we have negative 4 equals negative, parenthesis, x minus 3, close parenthesis. So back on the first one, if I simply add 3 to both sides, I get x equals negative 1. On the second one, I'm going to multiply both sides by negative 1 to get rid of this negative. Well, that turns my other 4, the 4 on the other side, into a positive. So now I have 4 equals x minus 3. Add 3 to both sides, x is 7. So for this equation, my zeros are 7 and negative 1. Okay, so, nope. Okay, so, critical values, turning points found at local minima and maxima. If we're looking at equations, so if I look at a graph, and this graph does this, I will see I have a number of turning points. These are critical values, these different turning points. Okay? In between turning points, it can be increasing or it can be decreasing. Sorry, my phone just buzzed at me. Nope, nothing. So if we look at these two critical points and we find the slope of the line between them, if it's negative, it's going to be decreasing, and if it's positive, it's going to be increasing. We always read these graphs left to right. So on this graph, it's increasing, then decreasing, then increasing, decreasing, and increasing. Okay? That looks like a hodgepodge, doesn't it? I apologize. But that's basically what this whole thing says. It also has a constant portion. So if I have a graph that does this, and it is constant in this section, I have critical points here and here, and between them they are constant. So this would give me a slope of 0 for this to be constant. Alright, critical values. Determine the intervals on which functions are increasing or decreasing, and determine relative minimum and maximum values of functions. Okay, find the local minimum. Local just means that between certain sections you're going to have a minimum value or a maximum value. Those are our critical points. In this case, notice if I use these 2 points, my overall slope is negative, so this is decreasing. Same with this last section. The overall slope is negative, so it's decreasing. Whereas between these 2 critical points, it's constant. We're also going to talk about average rate of change, which is very similar. The average rate of change is the slope of the line between the 2 endpoints. So if we're going to say I would like to know the average rate of change between 3 feet away from the pitcher and 20 feet away from the pitcher, we take 3 feet, we take 20 feet, and this would be our average rate of change or acceleration of the baseball. Okay, so this is how you would find that. All you're going to end up doing, notice, this is difference in the y's over difference in the x. It's slope. So that's all it is, just finding slope. Find the average rate of change for this particular function, x cubed minus 3x. All we're going to do is plug in these values. So for a, we need f of negative 2, and we're going to need f of negative 1. F of negative 2 is negative 2 cubed minus 3 times negative 2. Well, that's negative 8 plus 6. This gives me negative 2, so this point is negative 2 and negative 2. For this second one, f of minus 1, I have minus 1 cubed minus 3 times minus 1. Okay, so now this is minus 1 plus 3, or positive 2. So I also have the point minus 1, positive 2. If I look at the slope between them, I have, I have negative 2 minus 2 over negative 2 minus a negative 1. So here is negative 4 over negative 1. Changes those to positives. So the slope is 4, so the average rate of change is 4. Odd and even functions. We're not even going to have this on your homework or in the test. So you don't even need to worry about it. We're just going to skip. Alright, and you'll go do your in-class practice. Once you're done with that, your WebAssign. You will need to turn in your green sheets, either electronically if you've downloaded them, or hard copy if you picked one up at school.